Good morning, all of you. This is Venkatesh. Today we are going to discuss about our fifth unit in our network theory, the two-port networks. So, what is mean by port? What is mean by two-port network? Port is nothing but a terminal. So, here a pair of terminals at which a signal may enter or leave a network is called a port. A port is nothing but a pair of terminals. That means a plus and minus. That means simply you can take a simple network that is represented in our network rectangle box. Here a pair of terminals, that is plus and minus. One is entering, another one is leaving. This pair is nothing but a simple a port. Similarly, the two-port network means a network consists of two pairs of terminals. So that is one pair represents to input terminals and another pair represents to output terminals. That is called a two-port networks. So it can show the figure like this. So the network represent in always in the rectangle box. So here I am taking the 1 dash is one pair and 2 dash is another pair. So here 1 dash is input side and 2 dash is output side, two terminals. So two pair of terminals. That's why this network is called by two-port network. This network is called two-port network. So here V1, V2 are the voltages. One is V1 is input voltage, V2 is the output voltage, and I1, I2 are the input current and output current. So here the both currents are entered to the networks. The both currents are entered to the networks. So generally the two-port network parameters are classified like here. That is, one is Z parameters or impedance parameters or open circuit parameters. Second one is Y parameters or admittance parameters or short circuit parameters. And third one is H parameters or hybrid parameters, inverse H parameters or G parameters, ABCD or transmission parameters. So these are the classification of two-port network parameters. So here what is mean by impedance? So impedance is nothing but the ratio of the voltage to current in the AC circuits. That means alternating quantity. That means the resistance in AC networks is called impedance. So that's why impedance is denoted by a letter impedance. Impedance is simply so ratio of voltage by current. So that is nothing but it is denoted by letter Z. So it is nothing but resistance. So this resistance in AC represents with Z letter. So what are the units of impedance? Is in ohms. Unit says ohms. Similarly, admittance. So admittance is nothing but reciprocal of impedance. That means inverse of resistance in AC. That means what? I by V. So that means the reciprocal of ohms is nothing but mho. So this admittance denoted by letter capital Y. So impedance is in Z. So these are the type of parameters. So first we can see Z parameters in two-port networks. So Z parameters. So here the Z parameters, the voltages can in voltages expressed in terms of currents. So that is here the function V1 and V2 is a function of I1 and I2. So here I am taking a simple network. So here V1 is the input voltage and I1 is input current. V2 is the output voltage and I2 is the output current. So here I1 and I2 are entered to the network. So here the V1 V2 depends on I1 I2 value. That's why V1 and V2 are the dependent variables and I1 and I2 are the independent variables. So here I am writing the equation for the Z parameters. So Z parameters, that is Z11, Z12, Z21 and Z22. So these are Z parameters. So V1 equals to some constant Z11 I1 plus Z12 I2, V2 equals to Z21 I1 plus Z22 I2. So these two equations can write in the matrix form V1 V2, a single column matrix, that equals to Z11 Z12 Z21 Z22 I1 I2. So here it is the dependent matrix. It is a simple square matrix, that is a 2 by 2 matrix. So this is called Z parameters. It is Z parameters. So it is I1 I2. So how to calculate the Z11 value, Z12 value, Z21 value, Z22 value from the above equations? So we have the two equations, that is a V1 equals to sum Z11 I1 plus Z12 I2, and V2 equals to Z21 I1 plus Z22 I2. So you can choose, that means you can take any one value is going to be 0. You can take any one value is going to be 0 at the right hand side. So that means either I1 or I2. So you can put the 0 in the place of currents, so you can calculate the remaining factors. So that's why initially I am taking that if I2 equals to 0, if I2 equals to 0, if I2 equals to 0, from equation 1 I am getting that if I2 equals to 0 from equation 1, I am getting that what? So V1 by I1 equals to Z11. V by I ratio is nothing but impedance, that is I am writing as impedance. So in these terms V1 and I1 are the input values, and I2 equals to 0, that means there is no current. So under the open circuit there is no current, that is equals to 0. That's why Z11 equals to V1 by I1 at I2 equals to 0, that is write as open circuit, the input V by I ratio is nothing but impedance. And similarly Z12, that is at I2 equals to 0, in the from the second equation I am getting that Z21 equals to V2 by I1. So V2 by I1. So similarly I2 equals to 0 is present in the open circuit, and here we are getting current is in forward direction. That's why it is a forward transfer impedance, V by I impedance. And similarly Z12 at I1 equals to 0. So second step I am taking as if I1 equals to 0, I am calculate the Z12 from V1 by I2, that is open circuit. So here I2 is reverse, that means opposite side of the original. So that is enter to the network, that means reverse transfer impedance. And Z22 is V2 by I2 at I1 equals to 0, that equals to open circuit output impedance. So this is the Z parameters. So here the Z parameters is nothing but Z11, Z12, Z21, Z22. So under the reciprocity principle, so the parameters going to be Z12 equals to Z21. So here this is the Z parameters in two-port networks. Two-port networks. So this Z parameters is also known as open circuit impedance parameters. This Z parameters is also known as open circuit impedance parameters. So this Z parameters I can explain by using a one exercise. So one problem that is taken as like here. Here before I am explain the problem. So here I am drawing that one equivalent circuit. So here, so we have the parameters Z11, Z12 into I2, Z21 into I1, Z22, so V2. So here the loop, this is taken as a one loop. So it is I2. So that means V2 equals to I2 into Z22 plus I1 into Z21. So here the V2 is dependent variable, that's why here I am taking as dependent sources. So that value like this. So that is simply I am drawing the equivalent circuit of Z parameters. This is the equivalent circuit of Z parameters. So what is the problem here? So problem on Z parameters. So here I am taking a simple circuit like this. So determine the Z parameters. So what are the Z parameters? Z11, Z12, Z21, Z22. So this is the circuit. So you can initialize that first 1 dash and 2 dash in the quotient, that means in the circuit. So that is redraw the circuit and write the Z parameter equations, Z11, Z12, Z21, Z22, like here. So first you can take a condition if I2 equals to 0. Take the condition if I2 equals to 0. What is the I2 equals to 0? That is 2 dash is going to be open circuit. What I am doing here, open the secondary terminals output side. If open the output side, what happen, I2 equals to 0, but the voltage is present. This V2 is nothing but across the 4 ohm resistor. Here I2 equals to 0. The voltage is going to be presence, that V2 is nothing but voltage across the 4 ohms. So here by using this figure, so I am using the figure A. I am using the figure A. I am calculate that. So current, what is the total current in this circuit? I1. So I1 is nothing but total voltage by total resistance. That means what is the total voltage? V1. What is the total resistance? RT. So that is the first I can calculate that RT equals to total resistance from the figure A. So here 2 plus 4, these two are series and parallel to, and series 1 I am writing here, and I am calculate the 2.5 ohms. That's 6 parallel to, that is 6 to the 12 by 8, that is I am at 1.5, so that is 2.5. So that is, so then total current I1 equals to V1 by RT, V1 by 2.5, that is I1 in terms of V1. I am getting that I1 equals to 0.4 V1. And next I am calculate that, so the voltage across the 4 ohm resistor, so V2. So from figure A, voltage across the 4 ohm resistor is nothing but I4 into 4, so I into R. So the current passing through the resistor is calculated from there, from the figure. So here the voltage across the resistor is like here, that means the current into 4. So what is the current here? So that is a current passing to the 2 ohms resistor. So how to calculate the current passing to the 2 ohm resistor? Using the current division rule of this from in this circuit, then calculate the current passing to the 4 ohm resistor. So that's why I am using the current division rule. Total current into current entered to the node into opposite resistance 2 by sum of the resistances. So that's why I am taking as sum of the resistances, that is I4 equals to I1 into 2 by 2 plus 2 plus 4, that is a current value. So voltage V2 equals to I1 into 2 by 8 into 4, that is a V2 equals to I1 into 1. So therefore from the figure A, Z11 equals to V1 by I1, that equals to V1 by 0.4 V1, that equals 2.5 ohms. V by I, that is the impedance, that's the unit as ohms. Similarly Z21 equals to V2 by I1 at I2 equals to 0. Simply substitute the values. What is the V2 in terms of I1 values? That is a 1. So here we are getting the two values. Second case, you can take if I1 equals to 0, that is the input terminals 1 dash is open. So here I am open the input terminals, that means the I1 equals to 0, that means current passing to the 1 ohm is equals to 0, that means voltage V1 is across 2 ohms resistor and supply is connected to 2 dash, so that is the figure B. So from the figure B, again I am calculating the total current, that is I2. So I2 equals to total voltage by total resistance. So RT calculated from the figure B. So that is a, so 2 plus 2 then parallel to 4. So 4 parallel to 4, that is where I am getting the 2 ohms, and then I2 equals to V2 by 2, that is a 0.5 V2. So then again I am calculating the voltage across the 2 ohms. The voltage across the 2 ohms equals to 2 voltage V1 equals to current at 2 ohms into resistor 2. So current at 2 ohms is nothing but the total current I2 into opposite resistance by sum of the resistance. 2 plus 2 4, 4 plus 4 8, 4 by 8. So that is using the current division rule again here, and I am calculate the current passing through the 2 ohms resistor, that is I2 into 4 by 8. So that is substituted in this voltage across the, so 2 ohms resistor, so that is V1 equals to I2 into 1, and then calculate that if Z12 equals to V1 by I2 at I1 equals to 0, that is I1 that equals to 1 ohm, and Z22 equals to V2 by I2. So here I am substitute the value I2 equals to 0.5 V2, that equals to 2 ohms. So this Z12 and Z22 is calculated from figure B, and Z11 and Z21 is calculated from figure A. From figure A. So this is calculated from figure B. So this is the main thing. So finally I can write that Z parameters equals Z11, Z12, Z21, Z22 equals to 2.5, 1, 1, 2. So here it is in this problem we get the Z12 equals to Z21. That means it satisfies the reciprocity condition. This is the Z parameters in two-port networks. Thank you.